Good morning. I'm Richard Rockrohr. I taught physics for several years, but today we are in the Jackson County Historical Museum to look at a scientist, Robert Millikan, who was a graduate of Maquoketa High School in 1885. He was only a few kids in high school at that time, but he showed himself well. He went to Oberlin College, which is, both of his parents said were associated with Oberlin College, but he went there on a scholarship from a local man. After he was in Oberlin for 2 years, and he had taken one 12-week course in physics, his Greek and Latin instructor suggested that since they didn't have a physics teacher, that maybe he'd like to teach the intro to physics for the college, which he did, and he did that for several years. So I always looked at it as it's just incredible that, you know, your board job is actually teaching at the college that you are going to school. After he finished at Oberlin, he went to Columbia. He was a PhD program. He was the only PhD student. This is, physics was not a popular thing. All the physics was in Europe. After he went to Oberlin, he went postdoc and traveled mostly to Germany. One of the folks that he was there a year and a half, but one of the people that he was in close contact with was Max Planck, another famous physicist from Europe. Over a period of time, he basically knew just about everyone in Europe that was of the physics nature. He accepted a position at University of Chicago with Albert Michelson, who turns out won the Nobel Prize for his studies in light a few years later. 1904, 1905, Albert Einstein produced, he had 4 major papers, and one of them was a photoelectric effect. And basically that, the theory was that when light strikes a metal plate, it will knock off electrons if there's enough energy in the light wave. And Millikan set out to prove him wrong, and with extensive experiments, he actually verified the photoelectric effect. The experiment he's most famous for is the oil drop experiment, and that took quite a long time as well. They started out using water droplets, and very tiny, in a device that had a telescope to spot the little droplets in there, put a charge plates, and if the droplet had electrical charges on it, or it would, you could adjust the drops by adjusting the voltage on the plates. And later in the experiment, they went to oil drops, and the oil drop didn't evaporate so that the mass of the drop would be constant. He determined, with his graduate staff, they determined an accurate value for the charge on an electron. Between the oil drop experiment and the photoelectric effect, he was awarded the Nobel Prize in 1923. The photoelectric effect verification supported Einstein's theory, and that led to Einstein's Nobel Prize winners also. In World War I, and I need to mention this because we're going to talk about Matthew Lukish a little bit later, most of the scientists in the United States went to a National Science Council situation where they all gathered everything they could to support the science study of World War I. Millikan spent his time on detection of submarines, and Lukish, as I mentioned before, spent his time on working on camouflage. So, you know, it was like, well, what color do we paint the planes so they're not so easy to shoot, and all that kind of stuff, and submarines, so on. In 1921, Millikan was attracted to Southern California, to a college that used to be Thorpe College and was changed to, or they changed the name and changed the procedure to California Institute of Technology, called Caltech. And Millikan was the leader of the administrative council for that organization from its inception until the mid-1940s. Under his leadership, ability to fundraise, and it was all private funding, the first building they put up was a physics laboratory, but then they started a College of Chemistry. They did aeronautics, they did the biology. So some of the famous names like Richter were associated with Caltech, and Jet Propulsion Laboratory was started there, which if you can spell NASA, that's where that came. And I mean, the list is quite long. So yeah. We'd like to introduce Matthew Lukish today at the Jackson County Museum. He was a graduate of Maquoketa High School in 1899, and he went on to Purdue, got an electrical engineering degree. He's got a degree from Iowa State, and he's got a degree from what's now called the University of Iowa. In order to get through school, he had bought a trombone. He graduated from high school about at the age of 15, and a year or so later he ordered a slide trombone, which was kind of a new instrument for the time, and actually made his way through most of his college by playing professionally in different bands and stuff like that. After graduation, he about his only job was working for the General Electric, and he went to the General Electric Applied Physics Labs in Cleveland, Ohio, and stayed there for 40 years. Most of the time, he was the director of the research at General Electric. A side note that during World War I, he was part of a group of scientists that joined the National Research Council to support the war effort with the United States from a scientific point of view. His entire career, he was studying the effects of light on vision, and worked on the camouflage division of that effort, and primarily trying to determine what colors the planes, the boats, what camouflage really meant, and doing it from a scientific standpoint rather than from an artistic standpoint of what looks good. But so his position was, if you can make it invisible, that is a success. During his time at General Electric, he was spent his entire career on what you would call the science of seeing. So we have to remember that when Edison invented the light bulb, that was just a clear glass bulb with a kind of a bright filament in there, and it sort of replaced a kerosene lamp or something like that. But any of the types of lighting that we have today did not exist at that time. So basically starting with frosted bulbs, trying to determine how to build a bulb that gave you a equivalent of a daylight situation for photography. A lot of studying on what types of light and what levels of light were most important for academic achievement and doing different projects. And he's considered the father of seeing, or the wizard of seeing, or I'm not quite sure what it is, but anyway, he was the guy that was the leader to develop most of the lighting projects that we have today. I did want to read a short letter that was sent to Matthew Lukish right after World War I. The National Research Council, acting as the Department of Science and Research of the Council of National Defense, on March 16, 1919. Mr. M. Lukish NELA Research Laboratory, Nela Park, Cleveland, Ohio. Dear Mr. Lukish, since my own term as chairman of the Physical Science Division of the National Research Council is about to expire, let me express my hearty appreciation for the exceedingly important work for which you did for the Council. From a scientific point of view, we have no other memoir which is more complete or more carefully prepared than the one for which you wrote on the visibility of airplanes. Very cordially yours, Lieutenant Colonel R.A. Milliken, Vice Chair.